Welcome to Contemporary Math lesson for section 1D. We will, in this section, be analyzing some arguments. So, one thing I want to get out of the way very quickly, right up front, is that there are two types of arguments, and I will reveal those right now. We have inductive arguments and deductive arguments. So inductive arguments, we'll start here with inductive, start with specific premises and go to a general conclusion. This is what we usually end up calling a generalization. And we can say the conclusion is formed by generalizing from a set of specific premises. So here is an example of that. We have a premise that says bluebirds fly. And I want to make sure I say this for everybody out there watching this video. Premise is just a proposition, which I've talked about in previous videos. But a premise is used to build an argument, which is what we are going to be talking about, arguments. So the first premise or proposition is bluebirds fly. The next premise is hummingbirds fly. A third premise is cardinals fly. So from that, we can make a conclusion about all birds. So we had some specific things going on, and down here we can say all birds fly. So the next example down here for deductive reasoning is the exact opposite of inductive reasoning, where we have general ideas and then we make a specific conclusion. And there's a way we can do this. Let me see if I can do this live. There we go. So we have these premises and the conclusions. So a specific conclusion is deduced from a set of more general or equally general premises. So we have the first premise that says all doctors are intelligent. We have a second premise that says Dr. Jones is a doctor. And we have our conclusion that Dr. Jones is intelligent. Now, this makes sense if you think of this first proposition or this first premise as being a conditional statement in the following way. All doctors are intelligent. So that's basically saying if you're a doctor, then you're intelligent. And we can think of all of these statements that you'll see throughout this video. When you see all blank are blank, the first blank is part of your premise, and the second blank, intelligence, is part of your conclusion for the conditional statement. So in order to make this, have this make sense, we need to look at a Venn diagram. So here I'm going to call my doctors DOCS, and all doctors are intelligent. So what that means is doctors, this entire bubble of doctors is inside another entire bubble of what I'm going to call intelligent people. Now, we know this one little bit of extra information here. Dr. Jones is a doctor. So what I'm going to do is I'm going to let a little x represent Dr. Jones. Now the question would be is where would that x go in the Venn diagram? Well, we know Dr. Jones is a doctor, so I think we should place this x inside the doctor bubble. And now we can just take a real quick look and just analyze this. We say, hey, since Dr. Jones is a doctor, we would place the x inside this docs bubble. But this x is also automatically inside the intelligent people bubble. So this conclusion makes sense. And we're going to take a little bit of a deeper dive into finding out what a valid argument is and if an argument is sound or not. Next slide. We're not going to worry about that now. I just want to set things up. So right down here, I have this evaluating arguments. So we have an inductive argument does not prove its conclusion is true. So it has to be evaluated on its strength. An argument is strong if it makes a compelling case is made for its conclusion, and an argument is weak if the conclusion is not well supported. And so we will actually take some looks at examples on the next slide. So before I get into any actual examples, I want to just go over the basic forms of conditional deductive arguments. And that's basically what we're going to be looking at the rest of this video, deductive arguments. So you may have to go through and talk about some validity or invalidity, or maybe in the next slide I say not valid or invalid. I may use both. Anyway, so here we have just some different structures. Maybe we have two premises here. We have premise 1 and premise 2. And down here under this line, we have what we'll call the conclusion. So all of our arguments are going to have three statements, two premises and a conclusion. Well, normally we can say we have our conditional statement, if P then Q, and the second statement is going to change here. P. P is true, Q is true, P is not true, Q is not true. So what we are looking at is either the hypothesis or the conclusion. And if we affirm the hypothesis, that means the second statement will say the hypothesis is true. And if the conclusion is Q is true, then we have what we call a valid argument. In the second example here, we will affirm the conclusion. That means we will say, hey, here's the hypothesis and here's the conclusion, and the second premise is the conclusion is true for the conditional statement. If our conclusion is P is true, then we have an invalid argument. And then this continues here with denying the hypothesis and denying the conclusion. So we have our conditional statement with the hypothesis and conclusion. We say the hypothesis is not true. So we would say the conclusion is not true. That would mean that we have another invalid argument. And then denying the conclusion means we have our conditional statement and we say the conclusion is not true. So if the conclusion says the hypothesis is not true, then we would have a valid argument. Let's take a look at some of those examples. On this slide, we will be taking a look at evaluating deductive arguments. So a deductive argument is evaluated based on two criteria: whether or not the argument is valid, and it's valid if the conclusion follows necessarily from its premises. And it doesn't matter if the premises are true or false. If we can get to the conclusion clearly, then it is a valid argument. The other criteria is the soundness of an argument. And an argument is sound if it's valid and all the premises are in fact true. So let's take a look at some examples here. So we have three examples here. We're using Venn diagrams to determine the validity of an argument, the validity and the soundness of an argument. So what I'm going to do now is I'm going to just look at number 1 here. We have two premises: all fish live underwater, and whales are not fish. So from the previous slide, a couple things I need to do from the previous slides. The first is I need to rewrite this first premise as a conditional statement, like this. If it is a fish, then it lives in water. There goes our conditional statement. Now, the next thing I want to point out here very quickly is that we have a hypothesis. So I'll underline in this color red. This is the hypothesis, and this other part here is the conclusion for our conditional statement. Now, if we were just going to look at this very quickly, we can state just from reading these first two statements, all fish live in the water. So that says if it is a fish, then it lives in the water. Whales are not fish. So what we are doing here is we are negating the hypothesis. So we would say that this is denying the hypothesis, the second premise. We'll say denies, the hypothesis. And our conclusion denies the conclusion. It says, what is this? Whales do not live in water. Then it lives in water. We are saying the opposite of the conclusion of our conditional statement. So I can tell just by reading some sentences and doing some analyzing here that this is not a valid argument, aka invalid. But there's another way that we can look at this. There's absolutely another way we can look at this, which makes, I think, a lot more sense. And that is using the Venn diagrams as we are directed to do. So using the Venn diagrams, I can break down this conditional statement. If it is a fish, then it lives in water, like I did on the first slide. So I'm going to make a little bubble here. I'm going to call it fish. And I'm going to make a bigger bubble here, and I'm going to call it lives in water. So this is saying all fish live in the water. Now, here is what we are unsure of. I'm going to call x, my variable, whales. Now the only thing we know is that whales are not fish. So that means I will not put the x in the fish bubble. But for our second premise tells us where this variable should go. And the second premise doesn't tell us anything about whether or not whales live in the water or don't. So everything inside this big bubble lives in the water, and everything outside this big bubble does not live in the water. So what we have to do is we have to put this x right on the border, like this. Because just from premise 2, whales are not fish, that doesn't tell us whether or not they live in the water. So I have this premise 1 gives us the bubbles. Premise 2 tells us where the x should go. And if the x can be placed clearly in any bubble, so either in the fish bubble or in the lives in water bubble and not on a boundary or a border, then we would say it is a valid argument. But since this x is on the bubble, on the, we'll say the border, then the argument is invalid, which is exactly what we were able to figure out up here with this one. But I like the pictures a little bit more, so I'm going to be sticking with the pictures for the next two examples. So let's take a look at example 2. We have the premise is that if a person lives in Chicago, then the person likes windy days. So here are the bubbles that I've made using my first premise, my conditional premise, if, then. The hypothesis is a person lives in Chicago. The conclusion is the person likes windy days. Cool. The second premise tells me all about my variable, and my variable this time is going to be Carlos. And it says, the second premise says, Carlos lives in Chicago. That puts this x inside this inner bubble, right there. This x, unlike the last example, is not on a border. It is clearly entirely inside one of the two bubbles. So that would make this argument valid. Just take a listen to these statements. If a person lives in Chicago, that person loves windy days. Carlos lives in Chicago. Well, based on our first premise, that means our conclusion is Carlos likes windy days. Very good. So this is, in fact, a valid argument. Next, and I'll get to example 3 here in a couple minutes, I want to talk about the soundness of these arguments. In order for an argument to be sound, it has to be valid. So if an argument is invalid, then the argument is also not sound. It has to be valid before it can be sound. All right. So the first argument here is definitely not sound. Like the conclusion that whales do not live in the water. Whales definitely live in the water, so this is not a sound argument. Anyway, the second example here, we have let's see, if a person lives in Chicago, then the person likes windy days. Carlos lives in Chicago. Those are both true. And if they're both true, then our argument is sound. So we can only have a sound argument if it is valid. So that's why we have to check whether or not the argument is valid first. So again, a valid argument means the conclusion follows from the two premises. And a sound argument means the premises are true. Let's take a look at the third example. The final example on this slide says, if an employee is regularly late, then the employee will be fired. So here's our conditional statement, and the bubbles will look like this. There we go. The hypothesis, an employee is regularly late, that bubble will always be inside the conclusion bubble. Then the employee will be fired. All right. Next, Sharon was fired. So I'm going to call X Sharon. Now, this is a funny X. Where should we place this X? Well, the only thing we know about Sharon is that she was fired. So I know for sure the X has to be in this big bubble. But we don't know anything other than the fact she was fired. So what I have to do is first explain that in this bubble, these are all the people who were fired because they were regularly late. Everywhere outside of this bubble, but inside the fire bubble in here, these are people who were fired for other reasons. Now, we don't know what reason Sharon was fired. So I have to put her on the border for this regularly late bubble. We have no indication. So I get to state right away that since this X is on a border of a bubble, this is an invalid argument. The conclusion being Sharon was regularly late. We don't know that. That could have happened, or it could have been because multitude of other reasons that I don't really want to get into on a video that multiple people will see. So this is an invalid argument, and you have to have a valid argument in order for it to be sound. So since this is invalid, it's automatically not sound. And I want to, make sure I do one more example of this just so I can say how this argument is being set up. So if we didn't have any of this picture here, from the previous slide, I know that was about 12 minutes ago. From the previous slide, it was stated that we have a hypothesis and we have a conclusion for our conditional statement. This premise is affirming the conclusion. So I'm going to say affirm the conclusion, which means we are taking the conclusion in the conditional statement to be true. So this would be Q is true, and the conclusion of the argument was P is true, and that's another way to show that it was an invalid argument. On this slide, we will be taking a look at the final two examples, example 4 and example 5. So again, the first premise that you will have for any conclusion that we will look at is going to be a conditional statement with a hypothesis and a conclusion. So the hypothesis bubble in our Venn diagram will always go completely inside the conclusion bubble. So if you like the book, you will automatically love the movie. All right. So when we take a look at the second premise, we talk about not liking the book. And this second premise refers back to the hypothesis of the conditional statement. But it's the negation, so we're going to say this denies the hypothesis, and I'm going to abbreviate HYP. So you did not like the book. So not liking the book just means that you are outside of this bubble. We don't know if you loved the movie or not. Everything outside the red bubble out here would be not loving the movie. So I have to take my x, my variable, u, and we have to put it on the border of this particular bubble, because the only thing we know is that we did not like the book, so we can't be inside or touching this bubble. But we do not know anything about liking or loving the movie or not. So the x has to go on this bubble, or on the border of this bubble here. So the conclusion ends up being, you will not love this movie. Well, we don't know. I just got done saying we don't know if we will love the movie. You could be in this bubble or you could be out of this bubble. We have no idea. So since we can not clearly mark this x either inside, completely inside a bubble, or outside of all the bubbles, we say that this is an invalid argument, and automatically it is not sound. But again, we could just take a look at the analyzing of just the statements. So we already know it's not valid and not sound, but just take a look. If we have if P then Q, we have this statement here that says not P. This denies the hypothesis, and our conclusion way down here at the bottom was not Q. So if you go back and look a couple slides ago at that table, this exact setup right here tells us the argument is invalid. And since the argument is invalid, there's no way it can be sound. All right, for the last example here, we have two premises. The first this time is not in a conditional statement. So that's the first thing you always need to do. So again, the first bit of this information here, narcotic. The second bit of this information here, habit forming. So here's our P. If it is a narcotic, P, our hypothesis, then it is habit forming, Q, that's our conclusion. So what our second premise states is that aspirin is not habit forming. And just to keep up with this, the second premise says not Q. It is not habit forming, right? Q over here is it is habit forming. Not Q is it is not habit forming. So not Q would end up being denies the conclusion. Okay, so we have all of this information. Let's set up our bubbles. So here we go. We have our first part, our hypothesis is the inner bubble. Our conclusion of the conditional statement is the outer bubble. But we know this. I'm going to call X aspirin. And it's not habit forming, so I have to place it out here. And guess what? This is, in fact, a valid argument. And that's because this X here is not on the border. It's not here, it's not here. It is clearly either 100% inside a bubble or outside of all the bubbles. So we have a valid argument. But this is not a sound argument. And that's because the second premise, aspirin is not habit forming, is false. It is absolutely habit forming. So this is not sound. So this is the only example you'll see where we have a valid argument that is not sound. And that wraps up the video for lesson 1D.